This lecture is on pumping lemma for regular set or regular language. So actually pumping lemma is a powerful tool that can be used to show that a given non-regular language is not regular. So if you are given a language that is not regular, you can use pumping lemma to formally show that the language is not regular. So this is the statement. Let L be the regular language, then there exists a constant n which is dependent upon the language, such that for every string w belonging to L satisfying a particular condition, that is length of w greater than or equal to n, we can break the string into three parts, w equal to x, y, z, satisfying two conditions, that is the middle string must not be epsilon. So length of middle string must be at least 1 and length of xy is less than or equal to n. Then according to pumping lemma, for all value of I greater than or equal to 0, the string x y raised to I z must belong to L. So here the middle substring y will be pumped 0, or even if you pump the middle substring y 0 or more times, still the string x y raised to z, y raised to I z must belong to L. That is the statement. Now given the language L is equal to a raised to n, b raised to n, such that n greater than 0. So basically this language is not regular, because if you try to design finite automata for this language, it's not possible. But that is not a formal way to show that the language is not regular. But you can use pumping lemma to show that a raised to n, b raised to n is not regular. So let us assume that L be regular. So this is very important. You have to assume that L is regular. Then let us take a string w equal to a raised to m, b raised to m with 2m greater than or equal to n. So length of w will be greater than or equal to n. It will satisfy that condition. Then we can break w into three substring. W equal to, let the breakup be a raised to m minus 2, a square, b raised to m. W equal to a raised to m minus 2, b square, a square, b raised to m, with here x is equal to a raised to m minus 2, y equal to a square, and z equal to b raised to m. Here it satisfies these two conditions. If you consider y is not equal to epsilon, satisfying the conditions y not equal to epsilon, and so if I take the string xy, length of xy is equal to, if I take length of xy, it will be a raised to m minus 2 into a square, concatenate with a square, it will be m, which will be always less than or equal to n. It will satisfy this condition, length of xy will be less than or equal to n. Then according to pumping lemma, for all value of I greater than or equal to 0, x y raised to I z must belong to L. Now you can our aim is to identify at least one value of I that violates this condition. So if it violates this condition, then that actually contradicts our assumption, because we assume that L is regular. If L is regular, then it must satisfy this condition. So our ultimate aim is to identify a value of I for which it fails to satisfy this condition. So let us take I equal to 0. What happens if I equal to 0? If I equal to 0, x y raised to 0 z will be equal to, what is x? X is a raised to m minus 2. Then y raised to 0 means 0 occurrence of y. So a square will not be there, concatenate with z, b raised to m. So if I take a raised to m minus 2 b raised to m, this particular string violates the condition to be satisfied by the language, set of strings that belong to this language. Here number of a's is not same as number of b's. So this does not belongs to L. That contradicts